Bismillahirrahmanirrahim. I must say, I have recorded this topic several times before for different reasons, and I actually just recorded this same lecture this morning, and I felt I was not sufficiently awake. It was kind of like boring type lecture, so I recorded it, I uploaded it, and then I deleted it. And so this is the second time I'm doing the same lecture on quadratic equations today. Now, I just wanted to suggest to the student that I care sufficiently about the student that I feel that, okay, the lectures has to be reasonably engaging. So, but there's a difference between lectures being engaging versus entertaining, see? And this is very important, and I just wanted to take a minute of your time on this. See, I believe a teacher's job is not to entertain the students, see? And Einstein was an Einstein because his teacher was a comical genius or something like that. So we have this thing that good teachers are like, they can entertain their audience. No, a good teacher needs to try to be engaging. It's not my job to entertain nobody, because it's not what I do for a living. Okay, and as students, we must understand that we can't expect all teachers to be even engaging, and we definitely should not expect teachers to be entertaining. It's not their job. If somebody wants to be entertained, they can go to do something else. So as students, sometimes we just have to shut up and sit down, open the book, and study. And that's their job, and it's not always going to be easy. And that's not life. Life's not meant to be easy. And the paradigm of life, baseline life, is challenging. So you can't always be searching for entertaining things or entertainment educators, because we'd be disappointed. It's because it's very difficult to find talent. It's very difficult for teachers to try and even be engaging, forget entertaining. So you can't always expect teachers to be like that. Sometimes, how about this? We reverse the roles. How come we don't ask the students, hey, how come you don't pay more attention? How come you can't sit still in your seat and pay attention for 2 minutes in a row? What's wrong with you? Right? How come we don't reverse it? How come the society's expectations is not to have higher standards from the students? Right? So these are important questions and how we approach education in general. And if a student is always seeking for entertainment and teachers to be fun and exciting, they will have a hard time in education in general. It's a sign of immaturity in my mind. It's like students are always like that, like sheep herding. They're not like students, like sheep, because they just want to be taken by a shepherd and show where the grass is, and then say, here, eat. There's no effort in it. Where's the effort from the student's part? Right? So one of the beauties of life is that when we accomplish difficult things that require us to show patience, perseverance, dedication, and focus and concentration. So this topic is a challenging one. It requires a certain degree of nerdiness on the part of the students, so to speak. But it's not like rocket science, So we just have to kind of buckle up, sit down, and just do it. I am doing this. There's a bit of comment here, only because this is the second time I'm recording the same lecture. Because I do believe it is a responsibility to try to be engaging. At least, I'm the world's best teacher, but I'm trying to be reasonably engaging. You follow? So there is a responsibility on the part of the teacher to try to think of what they're going to say to the students. But on the other hand, there's a responsibility part of the students to try to do their part, right? To try to do their part, to think about what they're doing in their own life and bring the best qualities of a student to the teacher, inshallah. So anyways, here I'm going to talk about some of the basic concepts about quadratic equations. I've suggested previously that this is a quadratic function. A quadratic function is a second degree polynomial function, and examples are these. That's the parent function. An example is another one like here. And here's another example. Now these are different because this is one term, right? It has 3 terms, and this has 2 terms. They're all slightly, but they're all quadratics because they're all second degree polynomial functions. So that is a quadratic function, okay? A quadratic equation is this. See, this is an equation, okay? There's no y in there. There's no input and output, which is what this is, okay? This is the independent variable, which is the input, and that's the dependent variable, which is the output. Here there's no input out, there's only x's, there's no y's. So with quadratic equations, okay, there's only like one variable, okay, and this is a function. So that's the first thing we have to understand. We have to understand the difference between a function and an equation. Okay, so this is a generic quadratic equation. Okay, generic meaning like, you know, a here and b here and c here, they represent some numbers. Okay, and whereas x is the variable. Okay, x is the variable. A, b, and c. A and b are coefficients of x, and c is the constant term. And this is an equation. An example of this would be like this: x squared plus 5x plus 6 equals 0. Now you don't graph these, you know. You like solve this for x. In other words, this is a statement. This statement says if I have a number in my mind, if I square this and I add it to 5 times that number and add 6 to that, I get 0. What number am I talking about? Right? It's like a puzzle. Okay. So what number, when you do this to it, will give you 0? Okay. So you can solve these quadratic equations. In other words, you can find out the value of x, okay, where you plug that in over there, it will make a 0. So you can solve these. To solve an equation means to find out the value of the variable that will make that equation a true statement. Okay? Will make that a true statement. So in solving quadratic equations, so here's the quadratic equation, and parenthetically I will put this equation over here as an example. Okay, there are 4 ways to do this. Okay, the first way is a painful, cumbersome way, and that's the graphing. You can solve this by graphing. We'll talk about these individually: G-I-P-H-I-N-G. And that's painful. And the second way is by factoring. None of this is painful necessarily, just a figure of speech. Now, factoring, and this we have done before in Algebra 1, and that's, you know, you do one of these and you try to factor this into that and then solve it, right? And the third way is something else that students particularly like, and that's called completing the square. It's not difficult if you do it methodically. Completing the square. Okay, so the third way is completing the square, and finally the fourth way is using the famous quadratic formula. Okay, well, if you want to be an algebra student, you gotta know the quadratic formula, which is opposite of b plus or minus square root of b squared minus 4ac over 2a. You can't get away from this in your life until you're done with your career as a student, at least, or beyond. So you gotta know the quadratic formula. X equals opposite b plus or minus square root of b squared minus 4ac over 2a. You guys just kind of, you know, do whatever it takes to memorize. So there are 4 ways. So first way is by graphing, the second way is by factoring, the third way is by completing the square, and the fourth way is by using the quadratic formula. Okay, so today I'm going to talk about this because that's usually a good starting point for learning this. Okay, so let's take the example that we have: x squared plus 5x plus 6 equals 0. Okay, and try to solve this. Okay, so our instructions are to solve. Okay, to solve. So what we do is we factor. Okay, if you recall, factor is the opposite of FOILing. Okay, so these are like you know, opposite things. They undo each other, so to speak. So when we factor, what we try to take this to a binomial like this. Okay, and you can't get away from factoring and FOILing. You know, if you're weak in this, you gotta just put the effort and just try to learn it. Okay, so the way you factor, and this is going to be a review, so I'm not going to go in extreme detail here. The way we factor, you recall, is to you look at the first term to determine what goes over here, right? And then you look at the last term to figure out what goes over here, okay? And you look at this sign, and then you look at that sign, okay? That's how we factor. So you look at the first term to figure out what goes here, you look at the last term to figure out what goes over there, and then you could look at this sign, and then you look at that sign. Okay, so, and let's do this. So first term, x and x. That's easy enough, right? If you put x here, that'll give x squared. Okay. And then you look at the last term over here, and you figure out the factors of the last term. Okay, so in this case, it's 1 and 6 and 2 and 3. So because whatever goes over here, 1 or 6 or right, or 2 or 3, right? They have to multiply to give the last term, right? Okay. And whatever goes here, whether it be this, whether it be this or this, they have to add or subtract to give this term. Because in the FOIL, if you remember, these two terms are like terms, and they add and subtract to give the third term. Okay, so whatever goes over there between these two factors, okay, has to add or subtract to give this. So let's put 1 and 6, which is wrong answer, but we'll work with it anyways. And in FOIL, okay, because we're doing opposite of FOILing here, so the first term is gives you that. The last term is derived from these, and the OI in the FOIL are these terms. Okay, it's kind of like smile, smile, big smile, small smile, like that. You know what I'm saying? So the OIs, the outers and the inners, okay, in FOIL, they have to add up to give you that term. So the outer here is 6x, the inner here is 1x. Do they add or subtract to give 5? Well, they don't add to give, but they can subtract to give 5x. Okay, so this might work. Okay, then you look at the sign over here. If this sign is the same, since this is the same, it says that, since this sign is positive, it suggests that both of these signs, whatever goes here, are going to be the same. So if this sign over here is positive, it says that this sign and this sign are going to be the same. It doesn't tell you it's going to be positive. It tells you it's going to be the same. You have to look at this sign to determine what they're going to be. Okay? So, for example, if you have ax squared plus bx plus c like this, right? Okay? So let's give an example here. X squared plus 5x plus 6. Here's one example. X squared plus 6 equals it. Now these are two examples, okay, on this side. So in this case we have this. So this says both the signs are going to be the same, and they're both going to be positive. It's going to be like this and this. This one says the signs are going to be the same, and they're both going to be negative. They're going to be like that. Okay? So this sign is important in determining what they're going to be. Okay? Now if it's like this, if this sign was, let's say, negative, okay? If this sign was negative, then this would say the signs are different. One is going to be positive, one is going to be negative, like, or negative or positive, like this. And the bigger product is going to be negative. We'll give an example of that, okay? Let's get back to our example over here. So now we know that the signs are going to be the same and they're both going to be positive, like this. Now the product is 1x and 6x. They have to add, right, to get 5. They don't add or subtract. We're not subtracting here because now we know what the signs are going to be. So 1x plus 6x. So they give 7x. So that's not going to work. So 1 and 6 don't work. So then we try 2 and 3. So let's put 2 and 3 over here. And then it says signs are the same, they're both positive. Okay. Now let's see what our boys are. The outer is 3x, the inner is 2x. Do they add? And now they add to give you 5x. So that works. Okay. So now we have factor this. Now once we factor this, we change this one equation to two equations. Then we say x plus 2 equals to 0, or x plus 3 equals to 0. Why? Because see, if you have n 2 of anything and then multiply to give 0, if a times z equals 0, or x times out, or k times p, whatever, if 2 of anything multiplies to give 0, one of them has to be 0, right? How else are you going to get a 0? If two things are being multiplied, one of them has to be a 0. That's the only way you're going to get the product to be 0. So here we are. So you change this product like this into x plus 2 equals 0, or x plus 3 equal to 0. And then you solve this. You subtract 2 from both sides, and you get x equals negative 2. Right? How about this over here? Subtract 3 from both sides, so x equals negative 3. So now we get two answers, right? X is negative 2, or x equals negative 3. So this equation has two solutions. In fact, a quadratic equation it's a second degree equation, can have two solutions, one solution, or no solution. So the maximum number of solutions a quadratic can have is two solutions. The degree of the equation gives you the number of potential solutions. Okay, well, let's see. If that's a solution, if I substitute that in the original equation, I should get the I should make this a true statement, right? So let's try negative 2. So if I try, I'm checking over here. See, I'm being a good boy. So I'm checking. So negative 2 squared plus 5 times negative 2 plus 6, does that equal to 0? Okay, let's see. Negative 2 squared is 4. 5 times negative 2 is negative 10 plus 6. Does that equal to 0? Okay, 4 minus 10 is negative 6 plus 6. Negative 6 plus 6 is 0 equals 0. That is true indeed. So this works. So let's try negative 3. Okay, let's try over here. Negative 3 squared plus 5 times negative 3 plus 6 equals 0. Okay, negative 3 squared is 9 plus negative 15 plus 6. Does that equal to 0? Okay, 9 minus 15 is negative 6. Negative 6 plus 6 is 0, and 0 does indeed equal 0 last time I checked. So both of these work, so there are two solutions to this equation. So here's one example. I like to do two more examples before we finish and show. Here's another example. X squared plus x minus 12 equals 0. Okay, so this is a quadratic equation, right? So let's try to factor it. Since we know there are 4 ways of solving quadratic equations, let's try factoring is one way. Right, here we go. I put the scale. I mean, if you know how to factor, just put this in there, and just start praying or something like that. But at least get a start like this, right? So put these parentheses over there, and then x times x. Well, x times x will give you x, so that's the easy part. Now we have to figure out what goes over here. To do that, we have to figure out where the factors of 12 are. So here's your thinking space. See, here's like your thinking space. 1 and 12, 2 and 6, and 3 and 4. I usually try, if I have like a bunch of these over here, I try like the middle one, unless I can see something that's going to work, okay? And, well, I'm going to try 2 and 6, okay? 2 and 6. Now, the products here are going to be 2x and 6x, the oys, the outers and the inners, okay? The little smile and the big smile. They have to add or subtract to give you this, 1. There's no way you're going to add or subtract 2 and 6x to get it 1, so this actually does not work. And this is not going to work either. So, well, 2 and 6 doesn't work, so forget that. And I just know it's not going to work, but you can try if you want to. But I'm going to try this then. 3 and 4. Let's see what the oys are, the outers and inners, the biggest and small eyes. Small. So this is 3x and 4x. They have to add or subtract to give 1. Oh, they do. Okay, that's cool. That works. That seems to work. So now we just have to figure out the signs, right? Now here we have a negative. This says the signs are going to be different. In other words, this is going to be positive, this is going to be negative, or this is going to be negative, this is going to be positive. They're going to be different. Okay, so we just have to figure out which way it's going to go, right? So they're going to be different. Then you look at this one. This one's positive, and that being positive suggests that the bigger product is going to be positive. So whichever the sign belongs to, so the bigger one of these is going to be positive, okay? In this case, it's like the bigger product, right? So we're going to put positive over here and negative over here like that. Okay, and that's factored. So, we're going to factor this. It's going to work. So they're different, and the bigger product is positive. It's going to be like this. Good. Now we can divide this into 2, like this. So x minus 3 equals 0. So x plus 4 equals 0, right? This equals 0, or this equals to 0. And then we solve this. We add 3 to both sides. We get this. And you subtract 4 from both sides. You get x equals negative 4. Don't try to rush these, unless you're sure you know what you're doing. It's like that. Okay? So here's the answers. There are 2 answers here, okay? Easy enough, inshallah. I'd like to do one more example before I finish, inshallah, and that's this one. So 3x squared plus 10x minus 8 equals to 0. Alright, let's factor this. Alright, now see, this one is a little trickier. This is an equation. You put that there. Because there's a 3 here. If it's a 1 here, if there was only a 1, you would just put x and x, but it's not just 1. There's a 3 there. So we're going to have to put something over here that multiplies together. Well, let's put 1x and 3x, because 1x and 3x will multiply to give you 3x squared. Right? Fortunately, those are the only factors over here. If this was a factor, but if that was a 6, then you have to consider the factors of 6, like 2 and 3 and like that. Then you have more combinations of stuff to try to do. Okay? So, what's that? And over here, well, let's see what the factors of 8 are. 1 and 8, 2 and 4. And that's it, right? So, let's try 1 and 8. Let's put 1 and 8. So it could be 1 and 8 or 8 and 1, right? Because now it's going to be different depending on which one where I put it. So let's try 1 and 8. So then I do the oys, the outers and inners. So this is 8x and 3x. So this and this has to add or subtract to give 10. There's no way you can get 8x and 3x and make 10x out of it or somehow, unless you do some funny math. So that's not going to work. But before you give up though, let's try the other way. 8 and 1. That's not. That's even worse. This is 1x, and that's like 24x. There's no way you can get that 10 out of those. Okay, so 8 and 1 is just not going to work. It looks like so. Just cross that out. Thankfully, we only have one other choice here, and then let's see, 2 and 4. Okay, so then you do the oys again, the outers and the inners. 6x. Oh, 6 and 10. Well, that seems to work. Okay, let's try that. Okay, so then we look at the signs. Okay, these are going to be different. The bigger product is going to be positive, so it's going to be different. The bigger product is this, so that's going to be positive, and that's going to be negative. Now, but when you do that, see, now you have the signs. Positive 2x times 3, positive 2 times 3x will give you positive 6x. Negative 4 times 1x will give you negative 4. But if you add these now, you don't get 10x, you get like positive 2x. So this actually does not work, even though, you know, this initially it seemed like it would work. So we're stuck, right? What does that mean? We're done, right? We can't do this, right? Call it quits. No, what you do is you switch it. Try 4 over here and 2 over here. Before you give up on this, you have to try it both ways, because now these are different, because this is not 1x and 1x, it's 1x and 3x. The products are going to be different. Okay, so before we give up, we switch them around like this. Now let's try it again. The outers is 2x, and this is 12x. Do they add or subtract to give 10? Oh yeah, they do. Okay, let's see, because 12 minus 2x would be 10x, right? Okay, so maybe this will work. Finally. Okay, so that seems to work. Let's try the signs. I shouldn't erase that. Okay, sorry. So let's try the signs. The bigger product is negative, so this is 12x. And this is 2x. The bigger product has to be negative. That's negative, and this is positive, right? So that's 2 positive 2x. The bigger product has to be positive. Like this. This is positive 12x. And this says the signs are different, and this says the bigger product is positive. So the bigger product is 12x, and this minus 2x. So when you add those two, you get positive 10x. So we've done it. We've factored. Woohoo! Okay, so here we go. So now we have factored this out. Then see, we do the same thing here. Then we say x plus 4 equal to 0, or 3x minus 2 equal to 0. Why? Because if you have a product that is 0, one of them has to be 0. Either this is 0 or this is 0. A equals 0 or B equals 0. That's the only way this can be. So we do this. So, and we solve this. You subtract 4 from both sides. X is going to equal to negative 4. And then over here, you solve this for x. You add 2 to both sides. 3x equals 2. X equals 2 over 3. Ta-da. Okay? Alrighty. So these are 2 answers. Now, if you wanted to really make sure that you got the right answer, you didn't make some silly math mistake, you would substitute this and you would do a check over here. And you substitute this and then you would check over there. And then you realize that you did it correctly, and then you pat yourself in the back, right? So I know these are correct because I got this example from the book. So we should go on and show. So we were talking about quadratic equations. This is a summary, and I shall finish after this summary show. So when you have a quadratic equation, there are 4 ways to solve this. The first way is by graphing. The second way is by factoring, which is what we did today. I would request you to do a lot of problems with this and be very good at it. And the third way is by completing the square. And the fourth way is the famous quadratic formula. And that is x is equal to opposite of b plus or minus square root of b squared minus 4ac over 2a. So these are the 4 ways of solving quadratic equations. We talked about this. Inshallah, next time we're going to talk about this, and then we're going to complete the rest of the methods. We also talked today about teaching versus teachers being entertaining versus engaging. And I hope I didn't ruffle your sensibilities. I do care about my students, inshallah. Until next time, as-salatu wa-salamu ala rasulillah, alhamdulillah rabbil alameen. Assalamu alaikum.